The toughest challenge in warfare isn't firing the opening round, it's feeding your troops on the 10th morning. We've dedicated over 10 episodes demonstrating how the U.S. Navy systematically demolished Iran's military capability, vessel by vessel, installation by installation, production facility by production facility. You've learned the hardware, the targeting systems, the tactical geometry, yet despite all that overwhelming force, the Strait of Hormuz remains shut. Every channel poses the identical question: who's going to reopen Hormuz? That's the wrong question. The correct one is more straightforward and more difficult. When Marines establish positions on Abu Musa and the Tums, who's supplying them on day 2, day 10, day 30? Taking an island requires 24 hours. Maintaining control requires ammunition, diesel, drinking water, rations, and trauma care. Every single day with explosive hazards in all directions. Zero port infrastructure, zero roads, zero supply warehouses within 300 nautical miles. So what's your solution? Airlifting everything isn't fast enough. Conventional vessels can't navigate minefield waters, and you can't construct a supply base on hostile terrain that was under fire yesterday. 2 vessels are currently steaming across the Pacific toward Hormuz. Their names won't appear in any news cycle. Portland, Comstock, and they're carrying the solution: the mechanics of survival. If you want to grasp why the ships absent from headlines determine victory, subscribe to Navy Decoded. Because the exact problem that nearly cost Britain the Falklands in 1982 is precisely what awaits Marines at Hormuz. We've covered USS Tripoli's arrival at Hormuz. We've explained USS Boxer's accelerated deployment following the Ford incident. But both analyses omitted one critical factor, the one that genuinely determines whether Marines make it past week 1. Sustainment. Day 1, the invasion. Violent, rapid, overwhelming. Day 5, HIMARS munitions depleted. Day 10, power generators require components. CVs need new track systems. Day 15, Marines require potable water, prepared meals, and 3 need immediate surgery. Not a corpsman with basic equipment, an actual surgeon with a functioning OR. Correct, both Boxer and Tripoli have medical facilities, but those platforms are dedicated to offensive operations. Boxer is launching F-35B missions continuously. Tripoli is conducting F-35B strikes and MV-22 assault waves. She lacks a well-deck, pure aviation platform. Their medical facilities are already processing battlefield casualties from the initial assault. When sustainment phase kicks in, day 5, day 10, day 30, you require additional medical infrastructure that isn't competing with combat operations for deck space, surgical time, or patient beds. This isn't hypothetical. The British paid in casualties in 1982, May 25th, Falkland Islands. 2 AM-39 Exocet missiles launched from Argentine Super Etendards hit the container vessel Atlantic Conveyor. Not a warship. She was transporting helicopters, 3 Chinook heavy lifters and 6 Wessex helicopters destroyed. In one strike, Britain lost the aircraft that transported ammunition, fuel, and wounded across terrain. Ground forces had already deployed. They maintained their positions, but the logistics network behind them broke down. Ammunition consumption exceeded projections by a factor of 4 times. Nobody accurately predicts supply burn rate until combat begins, and without heavy lift helicopters shuttling those supplies forward, the entire operation nearly ground to a halt, not from enemy action but from supply chain failure. Now examine Hormuz and draw parallels. An MV-22 Osprey hauls approximately 10,000 pounds cargo on external sling load, adequate for emergency resupply, inadequate for continuous operations. A Marine battalion occupying an island consumes more than that daily. You require something substantially larger, something capable of moving 60 tons per run, 120,000 pounds, 12 times an Osprey's capacity. You need transport large enough for an M1 Abrams main battle tank, or a HIMARS system, or a month's worth of fuel containers across water and through minefields. That transport is the LCAC landing craft air cushion. Boxer operates 3, Portland operates 2, Comstock operates 4. But Boxer's LCACs are committed to assault operations. They deliver initial marine and armor waves to shore. Once that insertion completes, Boxer's well-deck transitions to retrieval missions. The platforms running logistics shuttle, the round-the-clock resupply rotation, are Portland and Comstock. Two vessels, two entirely different configurations. One sustains personnel, the other sustains equipment. This is why both are essential. Let me demonstrate what each actually accomplishes, beginning with the one carrying a hospital. USS Portland LPD 27 San Antonio-class amphibious transport dock. 684 feet of steel constructed around one concept. Keep Marines operational after the assault concludes. Start with medical capability. 124 patient beds, 2 surgical suites, dental surgery, X-ray, laboratory pre-positioned on a 25,000-ton hull stationed outside mine danger zones. The closest shore medical facility is Naval Support Activity Bahrain, 300 nautical miles distant. A medevac helicopter at 140 knots needs over 2 hours. In 2 hours, a trauma casualty requiring surgical treatment doesn't make it. Portland eliminates that delay. Osprey extracts wounded from the island, 12-minute flight to Portland's deck, and the patient is in surgery before that medevac bird would have reached cruising altitude. That's the difference between a field hospital requiring 48 hours minimum construction and a surgical center already operational, already crewed, already sterile. But Portland isn't merely a hospital. She carries 699 Marines, 14 armored fighting vehicles, Humvees, and a well deck operating 2 LCACs. Portland can insert an assault element and sustain it. And there's the capability that connects this platform to a concept we covered 3 episodes back. In 2020, Portland became the first amphibious vessel to neutralize a drone with directed energy. Not a laboratory test, not a computer model. An actual unmanned aerial vehicle destroyed by a 150-kilowatt solid-state laser, the LWSD Mark II manufactured by Northrop Grumman. In 2021, Portland fired again in the Gulf of Aden and eliminated a surface contact. Cost per engagement is measured in electrical power, pennies versus a rolling airframe missile at nearly $1 million per unit. In our episode on Odin and Helios, we demonstrated directed energy on destroyers. Portland proves the technology extends beyond warships. An amphibious transport dock, a hospital platform, now defends itself with photons. That matters at Hormuz. Iran still possesses missiles. Stockpiles remain even after we eliminated production facilities. Strike operations have degraded their coastal sensor arrays, but not every battery is gone. The surviving weapons still require one element to be lethal: targeting information. And the most economical way to acquire targeting information is reconnaissance drones. Launch a Shahed to locate the LCAC convoy, broadcast coordinates, direct a fast attack boat or shore-launched missile to intercept. Portland's laser incinerates that drone before it broadcasts a single image. Kill the sensors and the missiles go dark. Cost to Iran, tens of thousands per drone. Cost to Portland, electricity. Calculate the attrition mathematics. Portland sustains personnel, treats casualties, and secures the supply route with directed energy. Now meet the platform that sustains equipment, USS Comstock LSD-45 Whidbey Island. Class dock landing ship, 610 feet, 16,000 tons, and the most expansive well deck in any operational amphibious vessel in the U.S. Navy. 440 feet long, 50 feet wide. That's not a compartment. That's a hangar integrated into the ship's hull, engineered for one function: launching and recovering LCACs at industrial pace. Portland operates 2 LCACs. Comstock operates 4. With vehicle ramp elevated, she accommodates 5. Comstock doesn't execute assaults. She executes logistics. LCAC out, loaded with 60 tons ammunition. LCAC returns empty. LCAC out again, loaded with fuel containers. LCAC returns, cycle, repeat, round the clock. One LCAC run delivers 60 tons, sufficient ammunition and fuel to sustain a 500 Marine battalion for 48 hours. Without Comstock's LCAC fleet, there are no armored vehicles on the island, no HIMARS, no generators, no spare parts. The assault succeeds and then it starves. And here's the detail that makes Comstock's deployment remarkable. According to the Navy's 2020 long-range shipbuilding plan, Comstock was scheduled for decommissioning this year. Retired, scrapped. Instead, she's crossing the Pacific loaded with 4 hovercraft carrying combat supplies toward the most contested choke point on Earth. A platform that was supposed to conclude her service in 2026 is now executing the most critical operation of her entire existence. But none of that functions if the craft inside her hull cannot traverse a minefield. And this is where the technology gets remarkable. Now go deeper. You've seen us reference the LCAC before. This time we explain how it operates because the physics is what makes the entire supply network possible. The LCAC rides on a pressurized air cushion 4 feet above water surface, 4 gas turbines, Avco Lycoming, TF40Bs, producing 16,000 shaft horsepower combined. That power drives 2 systems simultaneously, 4 centrifugal fans inflating a rubberized skirt beneath the hull creating the air cushion, and 2 shrouded propellers driving the craft forward exceeding 40 knots fully loaded. The 4-foot air gap is the decisive variable. Pressure-activated naval mines, the most prevalent type Iran has dispersed throughout the strait, require direct physical contact or substantial pressure displacement to activate. A 60-ton hovercraft distributes its mass across the complete surface area of the air cushion. The point pressure on water beneath it falls below the activation threshold for mines calibrated for the concentrated keel pressure of steel-hulled vessels. The LCAC glides across the minefield. The mines don't trigger, but pressure mines aren't the sole hazard. Magnetic influence mines detect variations in Earth's magnetic field generated by large steel structures. Acoustic mines detect engine acoustics. Against these, the LCAC isn't undetectable. It contains steel. It produces noise. This is why the approach corridor must be sanitized first by specialized mine countermeasure platforms, literal combat ships deploying unmanned sweep systems. We demonstrated how the LCS accomplishes that mission 3 episodes ago. Once that corridor is sanitized, the LCAC crosses at 40 knots, too rapid for any remaining threat to reacquire it. How does an LCAC launch from a vessel? The sequence begins inside the well deck. The ship floods seawater through ballast systems, lowering the stern until the well deck reaches sea level. A massive stern gate opens. Imagine a garage door the width of a structure, but here's the technical surprise. The LCAC doesn't require a flooded deck. It needs only 0 to 6 inches of water over the threshold. The crew inflates the air cushion while the craft remains inside the ship, and the LCAC glides out on its own cushion, hovering across the deck edge into open ocean without ever contacting water deep enough to float a traditional boat. The expense of this capability, 1,000 gallons fuel per operational hour. Logistics to enable logistics. That's why you require a dedicated well-deck platform like Comstock with 4 LCACs and bulk fuel reserves. Not a carrier, not a destroyer, but a floating depot with a stern gate. Portland sustains personnel. Comstock sustains machinery. But if you only deploy one, the system fails. And that's precisely what the Boxer Amphibious Ready Group was configured to prevent. Let me demonstrate what occurs when all 3 platforms operate as one integrated system. Day 5. After the landing on Abu Musa, the island is controlled. Marines occupy every defensive sector. HIMARS launchers are positioned, dominating the shipping lane, and the first supply crisis emerges. HIMARS ammunition is consumed. 3 Marines require immediate surgical treatment. An ACV's powertrain needs components that don't exist on the island. Mines encircle every approach. A conventional landing craft would be forced to navigate through them at 5 knots, exposed and vulnerable. Comstock opens her stern gate. An LCAC inflates its air cushion inside the well deck, glides across the threshold and accelerates to 40 knots, 4 feet above every mine in the water. 12 minutes later, 60 tons of ammunition and fuel pallets arrive on the beach at Abu Musa. The LCAC deflates, offloads through its bow ramp, reinflates, and returns to Comstock for the next rotation. Simultaneously, an MV-22 Osprey launches from Portland's flight deck, transporting the 3 wounded Marines. 12 minutes. Flight deck to operating room. The surgeon is already prepared. Iran launches a Shahed reconnaissance drone to locate the LCAC convoy and transmit targeting coordinates. Portland's LWSD laser acquires the drone at distance. 150 kilowatts of concentrated light. The drone burns, no missile consumed, no fighter redirected. Pennies. Above it all, Boxer's F-35Bs fly combat air patrol, addressing the threats the laser cannot. Anti-ship cruise missiles, the surviving coastal batteries that SEAD operations haven't yet neutralized. The laser kills the sensors. The F-35Bs kill the weapons. 3 systems, 3 vessels, 1 formula. This is the Boxer Amphibious Ready Group operating as an integrated system. We covered the ARG in our episode on the Ford incident, but what we presented was the flagship Boxer, the assault carrier, the F-35Bs, the initial wave. What we didn't present was the infrastructure behind it. The ARG is 3 ships and each solves a different problem. Boxer attacks, Portland sustains the personnel who fight. Comstock sustains the equipment they fight with. Remove Boxer and you cannot assault. Remove Portland and your wounded perish. Remove Comstock and your HIMARS goes silent on day 5. Now layer the defensive systems against Iran's remaining capabilities. Mines, the LCAC hovers over them. Reconnaissance drones, Portland's laser destroys them for pennies per engagement. Fast attack boats, the A-10 Warthogs handle those. We demonstrated that equation. Shore-based missiles, SEAD degraded the installations. F-35Bs handle what survives. And Iran's own logistics, factories demolished, ports annihilated. No manufacturing, no importing, no resupply. The supply network sustaining the American force hovers above every barrier Iran positioned in its path. The supply network sustaining the Iranian defense no longer functions. If this transforms how you think about warfare, if you now comprehend that the ships absent from headlines determine victory, subscribe to Navy Decoded, because what we just presented is the equation nobody else is explaining. Who feeds the Marines on day 2, day 10, day 30? Portland sustains the personnel. 124 hospital beds, 2 surgical suites, Osprey medevac, and a laser that destroys the sensors of every drone Iran dispatches to locate the convoy. Comstock sustains the machinery, 4 LCACs delivering 60 tons per run through a well deck the length of a football field and a half, operating day and night across a minefield that halts every other platform in the fleet. Together, they complete the formula that Tripoli initiated and Boxer reinforced: not a raid, not temporary occupation, sustained presence, indefinite, self-sufficient, and protected at every level. Warfare doesn't conclude when ordnance falls. Warfare concludes when one side exhausts logistics before the other. Iran's factories are demolished, Iran's ports are destroyed, Iran's navy is on the ocean floor, and crossing the Pacific right now, a platform that was scheduled to retire this year is transporting 4 hovercraft toward the most critical mission of its entire service, sustaining 4,400 Marines at the far end of the world's most dangerous choke point. Logistics determines victory. Engineering determines logistics. And the 2 platforms nobody discusses are the ones that make everything else achievable.